Cool. So how we are going to do today is that I'm going to give you a question to solve. I want all of you to probably come up with a pen and paper and try solving it yourself, try drawing the UML. See that if you do not know design patterns, if you have no idea what are design patterns, how would you solve this question? And you just know solid principles, you want to follow solid principles and you want to make the code extendable, maintainable, all of that. Okay. So I'm giving you the question, all of you full attention over here. Yes, can I get more yeses in the chat? Yep. Okay, cool. So this is your question. So it is applicable for both Uber, Ola, and Swiggy, Zomato. So let me talk about this. If you have watched the videos, you might probably understand what scenario I'm talking about, but okay. So some of us are in tier 1 cities, some of us are in tier 2 cities, some of us are in tier 3 cities, right? When it comes to Uber, Ola, there are a lot of cabs in tier 1 cities, right? Like in Bangalore, Delhi, there are so many cabs. But in tier 3 cities, there are like very few cabs, right? So when you match drivers, so you have to do driver matching, right? That if there is a ride request, you have to do driver matching. In tier 1 cities, what is going to happen is that if you are over here, there are going to be a lot of cabs nearby, correct? Guys, can I get less of random messages on chat and more people concentrating, please? Random messages on Discord. Yes, thank you. Because I'll get distracted. Cool. So I am standing over here. I'm standing over here. And then there are a lot of cabs nearby. Okay. So now because I have so many options, I might want to assign the driver on the basis of, say, probably rating or the number of rides that the driver has already done for the day, right? And maybe based on some other factors, say on the basis of rating of customer, not just rating of driver, right? That if the rider is like a good customer, then I want to assign a driver which is of higher rating, something like that. Versus in tier 2 city, versus in say tier 3, tier 2 city, what is going to happen is that the cabs itself is so less, right? That I just want the nearest one. So only on the basis of location I want. My point is that I just want that based on some conditions, I want to be able to choose the algorithm runtime. You should understand my question. So basically the question is that sometimes it will be raining. Say, when it is raining, when the weather is bad, I just want the nearest driver. I don't want to care about the rating or about the number of rides that the person has taken on, anything like that. And in tier 3 cities or things like that, I want the nearest driver, right? So basically, I have multiple algorithms. Say there is one algorithm based on based on rating. So rating based algo. Then there is one, say, location based algo, which just gives me the nearest drivers. Then say there is another one on the basis of number of rides that the driver has taken or something like that, right? So there are different algorithms that I have. Now I have some conditions like, say, for example, weather conditions, rating, and all of that. The point is that there are some conditions, and on the basis of like runtime, I want to be able to decide that what algorithm I'm going to use. Okay, this is the question. It's okay. I know some people already know the solution. You don't have to see the chat. Just I'm going to stop talking for 1 to 2 minutes. Everyone pause and think how you would structure this. Take a pen and paper, try to draw the classes and try to see that if you have different algorithms for driver matching, how would you do this? I'm going to stop talking for 2 minutes. Okay. 2 minutes over. I hope everyone thought of a possible solution. Now, I guess the first naive solution that comes to all of our minds, I will just tell one possible solution and let's discuss the problems with it and what are the better ways of improving the solution. Let me know if you thought of a better solution also. Okay. So there is, say, a driver. I can see some people talking in the chat that there is one driver allocator manager. Okay. So there is one driver allocator manager. That's what Sandeep is saying. So I write this. Okay. Now inside this, so this is my class. Inside this, how is the code going to look? Suppose we are going to have a method which is going to return the driver. And it is going to be, suppose the method is match drivers. And inside this, we are sending some conditions that, okay, weather condition, this and that, and this and that. Okay. Now on the basis of this, how you're going to do is that if say location is equal to tier 1, just giving you a random pseudocode. Okay. So if this is the case, I am going to return some particular driver. I'm going to actually run the algorithm over here. I'm going to find the drivers according to the location or according to the weather conditions and do this. Else if, say the location is this, say tier 2, I'm going to run the algorithm and return accordingly. Right? Similarly, else if I'm going to run the algorithm and return accordingly. Right? This is the obvious solution, right? If we do not know anything else. We do not know anything else. For now, what am I doing? I just have a manager and I'm saying that I need to match the drivers. I have some conditions. Now, on the basis of condition, I am just deciding and I'm returning. Right? This is the naive approach. Correct. Now let's try to see the problems with this. Everyone, this understands, like this much everyone understands, right? That this is the naive approach, like a possible solution. Everyone understands this much? The problem, what we are trying to solve? Yes, everyone has understood the problem that we are trying to solve? Cool. Now, what are the problems with this? We know solid principles, right? Is it following SRP? Is it following SRP? Let's talk about that. So here we are running the algorithms. We are also deciding that which algorithm needs to be run. So obviously, I can see a lot of people saying no, no, no. So we are not following SRP, correct? Are we following OCP? OCP says what? That I should be able to add new code without modifying, right? I can see a lot of no's. Why no? Because see, if I have another algo on the basis of some more conditions, right? Right now there is if else. So if I have another algo that comes up, I'll not be able to extend it, right? So I will have to modify the code. I'll have to test it again. So this is not following OCP also. It is not following ISP also. Why? Because there is no interface and also it is not extensible, as you can see, Shubhit is saying. Yeah, we are not following DIP also. Why are we not following DIP? Say this class is the high level module and say these algorithms are the low level module. So there is no interface, like there is very tight coupling, right? So there is very, very tight coupling. That if this is the case, do this. If this is the case, do this. This is direct dependency, right? So there's a lot of problems with this. And we have seen similar problems happening, say in factory, that there are a lot of if else and we need to extend it and all of that, right? So I'm sure that all of you have understood the problems with this, right? We are not following solid principles. This is not extensible. This is not maintainable. And everyone has understood the problem that we are trying to solve. Is this much clear? The problem that we are trying to solve and why this naive solution is not good. Can I get yeses? Yes. Now, we all know from like so many classes that interfaces or abstract classes is the solution to most of our problems. Correct? Interfaces is the okay, I can see a question at how are we violating SRP? So if you think about it, there are so many algorithms that are running inside this. Firstly, there are multiple algorithms that are being run. And we are also seeing that if this is the condition, we'll run this algorithm. Say there are 10 algorithms inside this, correct? So there is no single responsibility. We are matching the drivers, but then we are also deciding that which algorithm to run and all of that. Someone is asking about the L principle. So list of substitution, actually we start talking about it when there's a base class, when there is a subclass, right? There is no base class subclass over here. This is just a class and one method that we are talking about. We have actually not done any inheritance and also there is no LSP over here, correct? So there's none of the solid principles are actually being followed if you think about it. Yes, makes sense? Main thing to remember over here is that we are violating OCP very nicely because it is not extendable. If we add new algorithms, we will have to test the code again. This is not extendable at all. Okay. So we know that interfaces, abstract classes solve most of our problems. We are very expert in that. So I guess one solution that most of you are thinking about right now is that we are going to have one interface. Suppose I'm going to call it interface algo, and I'm going to have different algorithms. I guess you guys are thinking about this, that algorithm 1, algorithm 2, algorithm 3. Yes? A good way to extend, right? So now if I do this, what am I doing is that I will be able to add new algo on the fly, and I will be able to remove one algo on the fly. Yes? I can see some people talking about SRP. See, SRP, if you remember the first class, it depends on context. It is subjective. What do you mean by the single responsibility? I am saying that here there are two responsibilities. And what are the two responsibilities? One is matching that what algorithm has to be run. Second is actually running the 10 algorithms. I want one responsibility as one particular algorithm, or one responsibility is deciding what algorithm to run, right? Remember, first class of SRP, we talked about that it is subjective. Yes. So that is why I am saying that main focus should be, or at least in this case, should be that we are violating OCP and we are violating DIP. Correct? Does everyone understand? Like, this much is, I think, intuitive to everyone, that we will have one interface and we'll have multiple algorithms. Because the problem that we are trying to solve is that we should be able to add algorithms, we should be able to remove the algorithms. Everyone understands this? Yep. Can I get more yeses? Everyone is able to understand this much, right? So now let's see that how our UML is actually going to look. So what I have done for now is, see, one technical term that I'm going to introduce now. When we say different algorithms, I'm saying different behaviors or different strategies. Different behaviors or different strategies. What is an algorithm? It is a particular behavior or a particular strategy to run a particular code. Correct? So algorithm, behavior, strategy, all you can use interchangeably, at least in this scenario. Yes. So algorithm is basically what algorithm to match the drivers, or the behavior or the strategy to match the drivers. You want to decide runtime that what will be my strategy that I want to use, or you want to decide the behavior runtime. Yes, as Atul is saying. So you want to decide the strategy runtime. So yes, we are talking about strategy design pattern, as a lot of you were already saying in the comments. Yes, strategy design pattern. Now let's try to see how the UML is going to look. How has it made our life so much easier? So I'm going to have a strategy, basically the I algo that we were talking about. And there are going to be different strategies. What strategies will implement the interface strategy? Concrete strategies. Now, I guess you all must be well aware of the terms, right? Interface, concrete. As soon as you say that you're implementing an interface, concrete terms should come to your mind. Yes. So we have concrete strategies. What are the concrete strategies? Say, for example, rating-based strategy, or say a location-based strategy, or something else, something strategy. Correct? Now, again, I know all of you are already thinking about this, that if it is an interface, we have to give some method, an abstract method, which these strategies will be forced to implement. Correct? Yes. So we'll have to give one method that these strategies will have to implement. Yes, I can see a lot of you are saying execute. So let's write execute only. So probably this is going to have an execute abstract method, which these guys will have to implement. So there will be an execute method inside all of them. Right? So essentially all of them are doing execution. Here, the execution will be on the basis of rating based. All of them will be returning drivers only, right? So driver. But the execution will happen, say, here on the basis of rating, here on the basis of location, here on the basis of, say, time, as Love is saying. Yes? Make sense? What are the red ones? Variables. No, these are classes. So this is one interface. This is the interface. And these are concrete. Let me make it beautiful. These are concrete classes or concrete strategies. Okay, should I write this again? Let me write this again. So there is one strategy. There is one execute. Making it properly for you guys. Okay, so this is the interface. This is the abstract method. Now we have multiple concrete methods. Why dotted line? Because interface. Remember, UML. So what are these? These are rating-based strategy. So this is the name. So there will also be one more. There will be data variables. For now, just understand. Yes. So this is not the proper UML. I am just drawing it for understanding purposes. So rating-based strategy, it will also have an execute. Similarly, there will be location-based strategy. It will also have execute. Correct? Same for, say, time-based strategy. Make sense? Implements. Correct. Yes, this much makes sense, right? This much is clear for everyone. So there is one driver matching strategy. Now the point is that who is actually calling the strategy? How are we deciding that, this strategy has to be followed and all of that? So remember, there was a class over here that we wrote, driver allocation manager, and it had all the code. So now what we are going to do is this driver allocation manager, we're still going to have it. I'm going to keep it over here. Driver allocation manager. Okay, now I'm going to pause for 1 minute and all of you take a minute to think about it. What should be the relationship between this driver allocation manager and this strategy? Let me say my question again. So right now, what was happening in this class? In the driver allocation manager, my entire if else was there. Now we said that there's a strategy separately and we have different strategies, right? So now this manager and this strategy, what should be the relationship between them? I can see a lot of people saying aggregation has a, okay. Some people are saying composition, Chaitanya is saying composition. Okay, I can see that a lot of you are saying has a already, like most of you are saying has a. I can see differences between aggregation and composition. Can you tell me in the comments, like why aggregation or why composition? Okay. For those who have, okay, I can see Subhadeep saying is a also. Okay. Let's talk about these possibilities one by one. So if you say is a strategy, is a driver allocation manager? No, right? So inheritance doesn't really make sense over here, correct? But my driver allocation manager is doing what? It is actually using the strategy to say execute something. Now, I can understand when you have the confusion between has and is, okay? But now when you think about it, that my allocation manager has a strategy to execute and get me the drivers. Doesn't it make sense? That it has the strategy to do this. Yes, if you have no idea about the design pattern, do forget about the design patterns. How would you write the code to make this extensible, maintainable? Yes, wouldn't you write has a over here? Wouldn't you like keep a strategy over here? Now, on the runtime, you can decide that whether it is rating-based strategy or location-based strategy. So manager has a strategy, right? Now I could see a lot of confusion between composition and aggregation. See, your strategy has to be of something, right? Like, so say there is one driver allocation manager. Suppose there is one Swiggy, Zomato is there. So suppose there is one, instead of rider, there is a delivery partner matching strategy also. Delivery partner matching or allocator manager, something like this. Now this has another strategy. So basically this strategy will belong to this class only and this strategy will belong to this class only, right? And one strategy will belong to a particular object, correct? That, okay, for this particular, like this particular case, I'm following this strategy, or this particular case, I'm following this strategy. Yes. So it is composition. Shobit is saying, yeah, I don't get it. Strategy pattern, have we studied in earlier sessions? So I understand that it can be confusing. For now, forget about the comparison and all of that. Focus on what problem are we solving. Okay, focus on that. We will do the comparisons of the design patterns. Okay. Piyush is saying, please explain the difference between association and aggregation. See, association would have been that I'm calling a strategy. Now, do you want multiple allocation managers to be using the same strategy? Is it a user? This manager is using this particular strategy. It has the strategy. I'm going to create this strategy when I create the manager. Otherwise, what is the point of strategy? Yes. If you do users, then either it will be like that there are multiple managers who are using the same strategy. Correct? So in this case, what I'm saying is that there is one driver allocation manager who has the strategy, and the strategy like cannot exist without this allocation manager. The entire life cycle of strategy is dependent on what? On this allocation manager. When I create the manager, I'm going to create the like this strategy variable, and then I'm going to use it and then do it. It is composition. The entire life cycle is dependent. Can I show the code also once? We will look at more examples. Can I show you the code? Okay, let's take one more example for which actually I've written the code. Okay, let's start from the starting so that you understand that what is the problem that we are trying to solve and everything. So now again, we are doing payment. Everyone, new example from scratch. Everyone, full attention over here. Yes. So I am trying to do payment. So there is a payment processor. Okay. Now again, inside this, I am saying that process payment or something like that. Okay. So process payment. And I am passing something like say amount inside this and the method from which I want to do the payment. And now inside this, what am I doing is that if the method is say credit card, if the method is credit card, then you do the payment in this particular way. Or if the method is say PayPal, you do the method in this particular, you do the payment in this particular way. If the method is say crypto, then you do it in a particular way, correct? This is the naive code. Then we talked about that, okay, this does not follow solid principles. Why doesn't it follow solid principles? Main reason is OCP and DIP, correct? OCP, how? Because if we add another method, we'll have to make a change over here. DIP, what? That, you know, the high level module, which is the payment processor, is dependent on this small, like how the payment is happening, right? So it is tightly coupled. SRP as well, because there are a lot of things that are happening inside this. SRP is subjective. Yes? This much makes sense. Again, same problem we are trying to solve, right? There are different algorithms, different methods of making the payment. It could be either through credit card or through PayPal or through crypto or whatever we want. So again, what am I going to do? I'm going to make a strategy, say payment strategy. And inside that, I'm going to have, say, credit card payment strategy and say PayPal payment strategy. Guys, don't make me draw the boxes again and again. You understand that these are the classes, okay? So this is the class name. All of them will have the abstract method. So it will have the abstract method of, say, make payment. And all of them will have to implement this make payment, right? So there is one, say, crypto payment strategy, correct? So now this processor will have this strategy. See, processor will have this strategy. Okay. Now I know there can be a lot of confusion behind aggregation and composition, correct? If you remember when we had talked about aggregation versus composition, we talked about it really depends on how you write the code, right? In this case, if I say that my strategy cannot exist without my processor, see, my payment strategy is going to exist only if the processor exists. That is my thought process behind composition, right? Why will my payment strategy exist if my processor is not there? If you tomorrow decide to design that my payment strategy can exist without the processor, someone else is also using it. But if you think in this context, does it make sense that your strategy is existing without the processor only? According to me, the entire life cycle of this payment strategy should be dependent on the processor. Yes, I will create this strategy. How am I going to do the payment? Only when I have the processor. If I do not have the processor, how are you even deciding that what payment method you are trying to follow? Correct? Yes, makes sense? No. So now what am I going to do is that inside this processor, that give me 1 sec. Okay. So what am I going to do is that inside this processor, I'm going to keep the strategy. So it has a relationship. So it will be what? Diamond shape. Just remember composition. Okay, let me show you the code. We will discuss more. Don't worry. Let me show you the code. Can you all see my screen? Yes. Can I get yeses on the chat? Okay, cool. So this is the CPP code that I've written. I'll walk you through both the CPP and the Java code. So here you can see that this is my payment strategy, which is the interface basically. It has the process payment, and as you can see, this is the abstract method. Let me open the Java code as well. So here you can see that this is the payment strategy, this is the interface, and this is the abstract method, correct? Because this is the interface. All of these concrete payment strategies will have to implement which function? This process payment. So you can see process payment, process payment, process payment, right? So whether it is credit card, whether it is PayPal, whether it is crypto, you're going to do it. Right now there is obviously one output statement, but you're actually going to process for this amount, correct? Make sense? Yes, this much makes sense that there is one strategy and then there are concrete strategies. Yes? Okay, cool. Now let's look at the main first. Let's look at the main part. So there is one processor, right? There's one processor, you remember inside this it was there. And then there is one strategy. We are creating the strategy over here. So this is of the interface type, payment strategy. But if you see, this is of the concrete type, correct? So concrete type is credit card payment. And this is the interface type. So what are we doing? We are saying processor dot set payment strategy. So inside this, we are saying that you use this strategy. Now let's look at the processor. So this is the processor. This was the class. If we did not know better, we would have written if else conditions inside this. Right now, what we have done is it has the payment strategy. It has the payment strategy. Now, how you write the code really matters. If you look at the code that I have written, I'm actually creating the strategy outside, right? I'm creating the strategy outside. So I have written the code for aggregation. If you think about it, let me actually write it over here. That I've written the code for aggregation, but is this the correct way? Can I create the strategy outside? If that is yes, then it can be called aggregation. But I would say the better way would have been that I create the strategy inside the processor. And we will talk about this also. Give me 10 minutes. I will talk about this also, that how this code can be improved. Okay. For now, what am I doing is that I am creating the strategy outside and I have this inside and I am doing a set payment strategy. So I am doing setting over here. So if you look from the code, you can see that my strategy is existing outside. So currently the code that I am showing you is of aggregation. Make sense this much? Yes, but it has a, right? It has a. So processor has a payment strategy. Yes, so you can see that payment processor has a payment strategy, right? So now inside this, what am I saying? When you do process payment, you just tell that this strategy has to process the payment. Now you see inside the processor, nowhere I know that who is the concrete strategy. I just know payment strategy. I just have the interface. I have no idea that what is the concrete strategy. So tomorrow, if I add another strategy, if I suppose tomorrow, other than credit card, PayPal, crypto, suppose I have another one, say Paytm or GPay. Right now, I'm not added those, right? So if I have those, I can make change. And you can see inside this, inside the payment processor, there will be absolutely no change. Still, you can set the payment strategy. Yes. Still, you can process the payment. Yes. But whenever you create the strategy and you pass it, you will just create a new one and you will pass it. Make sense? See, I know some beginners were getting overwhelmed that how will we know that this design pattern? The point is that these are very commonly occurring problems, right? And if you actually think about solid principles, you will only be able to design this, right? The crux you will only be able to get in. But what will happen is once you know the design pattern, it will hit you automatically. Oh, different algorithms. Okay, just make an algorithm interface, just draw different concrete algorithms, use a strategy design pattern. And you will start using this way of talking to your colleagues also. In interview also, you'll be able to say, this is the problem, this is how you can solve it. But if you actually think about it, you can start solving it yourself also. If this was the problem given to you, you would have been able to solve it yourself if you only knew solid principles. Correct? Yes. Yes, I can see some people talking about a very good problem over here, and that is the next thing that I'm going to talk about. But before this, there's one more thing that I want to share. So I'm stopping the sharing 1 second. Okay, let me share my screen. There is one problem that some people have noticed and have started talking about it. Can you all also think that what is the problem with the code that I actually showed you? There is one problem with the code that I showed you. Before we talk about this, let's quickly finish whatever we have discussed so far. By the way, this processor, this payment processor is called context. So when you see the UMLs of strategy design pattern, you will be able to see context. Okay. So let's see what are the main. So there are 3 components in strategy design pattern. One is context. One is the strategy interface. And one is the concrete strategy. Correct? So these are the 3 main components that are there. Yes, everyone agrees to this much? Yes, yes, no. Everyone awake? Yep. Awake, awake, awake. Can I get more awake? Yes. Cool. What is the context doing? Context actually has the object whose behavior we have to decide. Yes. So it has the, like, suppose, for example, payment processing. It is the processor, right? Driver matching allocator, the driver matching allocator. So it has the object. It contains the object whose behavior needs to be changed dynamically, right? So that is context, like payment or driver matching or whatever has to be done. So context has the object where actually this thing will happen. And now context will have this strategy also, correct? So context has a strategy. As you can see over here, context has a strategy, right? What is strategy? Here, a strategy interface is doing what? It is just common methods. It's just defining common methods that all the algorithms have to follow. Like over here, it is make payment, right? I could have probably have another one that verify payment or something like that, and that all of them will have to implement. Suppose a private method that is there, all the algorithms needed. So whatever basically abstract methods that all my strategies will have to have. This is basically they are setting the template, right? We are setting that this is the contract. These are the methods that all the concrete strategies have to follow. Yes. What is the concrete strategy doing? It is actually implementing the strategy interface, right? It is the actual implementation of the algo. So what is the concrete strategy doing? It is the actual implementation of the algo. Implementation of algo. This is where it was actually running. What is context? It has an object for which we have to decide the behavior dynamically or runtime. Yes. And there's strategy interface, which is just defining the common methods. So these are the main things. Now you will be able to draw the UML, you'll be able to understand, correct? Let's quickly talk about the advantages, disadvantages also. And okay, wherever we ask you, what is, like, how will you identify that this is a strategy design pattern? What are we doing in design pattern? In this design pattern, we have different algorithms, right? Different strategies. So we are encapsulating a family of algorithms into separate classes that implement a common interface. Encapsulating a family of algorithms is the key term. Encapsulating what? Family of algorithms. Like in factory, what we were doing, we were encapsulating the creation process. Here, what are we encapsulating? We are encapsulating the family of algorithms. Yes, encapsulating the family of algorithms. So there are different behaviors, different strategies, different algorithms. Make sense? What are the advantages? Quickly, I can see a lot of you are already telling yourself. we are allowing the runtime behavior. We can add dynamically that, okay, we want this algorithm, we do not want this algorithm. Maybe we can take the input and on the basis of input say, is it credit card payment or is it PayPal payment or what kind of payment it is, I can follow a particular strategy. Correct? We can add and remove algorithms. And also, we can remove, we can also test the algorithms separately, like we don't have to test them together. Now, coming to the disadvantage part. Before I talk about the disadvantage and the next variation that I want to talk about, has everyone understood this much? Like, I know there are some cons of this and we will talk about this. Have you understood this much? Can you please repeat context? Okay. What was context? See, basically the class, if you think about the problem, no, where the class where actually you would have done the payment processing, or the class where you would have actually done the driver matching. So context has the object like where we are doing the behavior dynamically. So this behavior, the driver matching was happening inside driver allocation manager, no? So now when we use the design pattern, what are we going to do? We are going to just remove this, and inside of this, instead of this, we are going to have a strategy, right? So context has a strategy, right? So now instead of context having that if else, now context will have strategy. Okay. Context is where we want dynamic or runtime behavior. Cool. Yes. Let me see more questions. Sujay is saying, can we go through the business for picking right strategy? Still, it feels like we end up using switch case, but replacing concrete class with interface. Good. So these are the disadvantages, and I'm going to talk about this right now. Where strategy comes in picture that you mentioned. Can you please repeat it? So this is the strategy, correct? So this is the payment strategy. These are the concrete strategies. Again, over here, if you see, this is the strategy. These are the concrete strategies. You can think of it as algorithm. Whenever you get confused with strategy, think of an algorithm, right? So there is an algorithm to do something. Then there are rating-based algorithm. There is location-based algorithm. There is time-based algorithm and all of that. Again, over here also, we started talking about this only, no, that there are different algorithms. So now it is better that I have different algorithms. Let's do a quick revision. Let's do a quick revision because I can see some people having the confusion. Okay. We are doing quick revision, everyone, full focus over here. So we started from the problem that we are trying to solve. What was the problem? That I am in tier 1 city, you are in tier 3 city, or you are in tier 1, I'm in tier 3, whatever. The point is the algorithm for matching the drivers or delivery partners is going to vary. Say if I am in tier 1 city like Bangalore or Delhi, I have a lot of cabs around. So maybe I want to use some other algorithm, some complex algorithm, which is based on, say, rating, number of rides and all of that. Versus in a tier 3 city, because there are such less number of cabs, I just want to run the algorithm on the basis of location. Make sense? So I want to run different algorithms runtime dynamically based on some particular condition. That was the problem that we were trying to solve. Yes. Now, while trying to solve this problem, I understood that, okay, different algorithms based on different conditions. So it came to you naturally that we will have an algorithm interface. So this will be the interface. So there is an interface and then there are concrete algorithms. This interface will say that, okay, you have to perform this particular action. Like you have to make the payment or you have to match the drivers or you have to match the delivery partners. And these algorithms, the concrete algorithms will actually perform this. Okay, the concrete algorithms will actually perform the algorithm. They will implement the algorithm. They will perform the action or they will implement the strategy. Strategy, algorithm, behavior, same thing. All three, same thing. Okay. Now, what did we say? I said that, see, earlier in this manager, I had, say, if else, right? Inside this manager. Now, inside this manager, I have a strategy. So this is called context. So my context has strategy. So it has interface, and then there are concrete strategies. Yes. So similarly, this is the payment processor was the context. Earlier it had if else. Now instead of if else, now there will be no if else, no if else. Instead of this, what will be there? Instead of that, it will have a strategy. So processor is the context. It has strategy. The strategy interface is payment strategy. All of them have to make payment. Make sense? Okay. By the way, if you have the doubt while talking to me, all the code before every class, I upload it on GitHub. So you can actually open it parallel and you can start looking at it also. Yes? Okay. Now, talking about the problem, I can see a lot of people talking about one problem, that in my main, I was still creating the strategy, right? In my main, I was deciding the strategy. Now, all of you said that you have not done composition, you have done aggregation, because you created the strategy outside and you did all of that, correct? Yes, I did all of that. Not a good habit. Now, what I want to do is that my client, whoever is using this, that the processor is saying that make the payment, or driver matching allocator, I'm saying match the drivers. I do not care about what strategy is used. Okay, it is your headache. So I want to create a strategy, but I should not come to know that how it is being created. It is your responsibility. So the creation of the strategy, I don't want to care about it. Now, what can we do to improve this? Let me repeat it. Let me repeat the problem that I am trying to solve. Now, in my main class, I do not want to create the strategy. I don't want to be the one responsible for creating the strategy. I don't even know about strategies. I just know that I want to make the payment, or I just know that I want to match the drivers. Correct? I can see a lot of people talking about factory. You are absolutely correct. You guys should feel so proud 3 weeks into the course and you are actually able to come up with the solutions yourself. And for those who were not able to think, it is fine. Think about it like this. What am I saying? I'm saying that strategy is used for different algorithms. Now I am saying factory. Why? Factory for creating the strategy. Now I don't even want to care about creating the strategy. Why should I want to care? I am just the client. I just want to know that process the payment or match the drivers. I do not want to care about how you are processing the payment, what strategy you are trying to use. Why should I care about this strategy? Make sense the problem that we are talking about? Yes? Yes? Okay. Let me say that again. Right now, I am the one who is creating the strategy. I'm the user. I'm the user of the processor. I'm the user of the driver matching. Basically, I'm the main. I don't want to know what strategy you are using. Whenever you want to use a particular strategy, add one strategy, I don't want to care. You do it. So I want someone else to be responsible of the creation. Let's look at the code and let's see how we can improve the code. Everyone can see the code? Yes? Yes? So in the GitHub also, you will be able to see basically two things. One is strategy design pattern. This is one folder. Another one is strategy and factory combined. So what are we trying to do now is we are trying to combine creational and behavioral design pattern. Creational, what does factory do? It creates something, right? What are we creating right now? We are creating strategies. And you will see this, like this is probably the most common thing. In my Uber Ola example, you'll be able to see. In my Swiggy Zomato example, you will be able to see. Because this is a very common problem. You will need different algorithms based on some condition. This is like the basic problem. Now, when you create strategies, now you want factory. So factory plus strategy is a very, very common problem that you will face. And it is extremely important for you to understand this, not just in terms of daily work, but also for interviews. So please full attention over here. Let's look at the code. Let's look at both C++, Java. Start with Java. This is the interface, payment strategy, right? So interface process payment is there. We'll also run the code, relax. So inside the interface, there is payment strategy, there is process payment. I have just passed the amount. These are what? These are concrete payment strategies, credit card, PayPal, crypto. We had already seen all of this in the strategy one, simple strategy one. We had already seen, yes? Yes, guys? Yeah? Okay. Now there is one payment strategy factory. What is happening inside this payment strategy factory? So here you can see that there is one create payment strategy and I am just passing the payment method. I'm just passing the payment method. Now you're saying that if there is credit card, you create the credit card payment strategy Or what are we returning? We are returning the strategy. I should have named it create credit card payment strategy, but okay, it would have been too long. PayPal payment strategy or cryptocurrency payment strategy. Otherwise, by default, I'm returning credit card payment strategy. So this is where I'm creating the strategy. What am I doing? I'm creating the strategy and returning the strategy. I know some of you will say now, this can also be improved, factory method and all that. You can do all of that. But obviously, we have to draw the line somewhere. So this is the most common one that is used at factory, simple factory plus strategy. Okay. Now, this is the payment processor. This is what? This is the context. So let me just write context. Okay. It has the strategy. It has the strategy. But now if you say about it, it is the one that is creating the payment strategy. It is the one that is setting the payment strategy. So what is happening inside main is, let's compare the main with the old one. So this was the old main. In the main, this is just the strategy wala main. Inside this, what I was doing, I was creating the processor, and then I was creating the strategy and setting the strategy, and then I was processing it. I was setting the strategy and then processing it. Correct? So I am setting the strategy. Versus now, if you look at this, I am not doing any of that. What am I doing? I am just saying that there is one input. There is one input, and I'm telling this processor that this is the strategy like that you have to use. Now, inside this is when I'm creating the strategy. The creation logic is where now the creation logic is with the processor. The creation logic is where in the context. So now, does this look like composition? That I am creating the strategy inside the payment processor. Yes? I'm creating it inside. Yes? Okay, and I'm processing it over here, process payment. C++ code also, let's see quickly. This is the interface. This is the abstract method that the concrete strategies have to implement. There's credit card payment, there's PayPal payment, there's cryptocurrency payment. If you see the factory, inside the factory, what am I doing? I'm returning the pointer of what? The payment strategy, right? See, the difference is only in the syntax, guys, only in the syntax. And I'm just returning one pointer. That is all that I'm doing, right? Here I'm creating credit card payment, PayPal, same thing I am doing. Here, this is the context. Context has the strategies. Context has the strategy. I'm creating inside this, right? Processing. I'm deleting inside this. So I'm creating inside and I'm deleting inside. This is composition. Creating inside, deleting inside. Composition. Like my strategy cannot exist outside, essentially. So in the main, what am I doing? I'm just taking, say, an input. Now, this could be an enum based on some UI, like the user selected that credit card. So basically, runtime, I'm just telling the processor that this is the type that has come to you. You process the payment. I don't care that what strategy is there. I don't care. I'm just telling that this is the user input that came and I ran it. Okay. Should we run the code? Should we run the code? So I'm in strategy design pattern. Let's run for both strategy and strategy plus factory. Okay. So currently I am in strategy. In my strategy, let's run for both Java and C++. So currently in this, so if I run payment, see here, processing the credit card payment. Here you see I had passed credit card. So I'm processing the credit card for 100. If I just change PayPal over here, if I just do this, I should get the output of what? PayPal, correct? Or what am I doing the change? Only in this, I'm changing the input and I should be able to see it. So let's actually run it and see. So if you do this, you can see. Oh, again, I saw credit card only. Why did this happen? Or did I not save it? Give me 1 second. Okay, am I in the right place? I think I am in the 1 second. I am in strategy design pattern. And did I make change in? No, I made change in the strategy plus that pattern. I'm going to go back to the strategy pattern. And in this main, I'm going to make the change. In this main, instead of credit card, I'm going to create PayPal. I was making change in the wrong place. Sorry. Okay. So now I am going to do this again. All right. Yes. So here you can see PayPal and PayPal, right? What did I do? I just made change over here. I made this as PayPal. Now, if I do Control Z, I just did credit card payment. Let's run it again. You can see credit card, correct? So what am I doing? I am just making change over here and it is happening by default, right? Inside how it is happening, I don't care. Let's run the one with both strategy and factory. So strategy and factory design pattern. Let's run the Java code. So strategy. So this is the Java code. Here you can see. So what should be able to see? Credit card 100 and then PayPal 50, correct? So let's run this. Oh, Java, sorry. Here you can see credit card 100 and PayPal 50. If I change this to say credit card, if I change this to credit card, I am only changing in the main. I don't care about anything else. How you do it, what you do it. I don't care about anything else. I should be able to run this, right? So payment demo.java. If I do this, this is just a warning. Yes, so here you can see processing credit card, processing credit card. Make sense? Yep. So what have we understood? We have not only seen one behavioral design pattern, but we have also combined one creational and behavioral design pattern. How do you guys feel? I am going to open your, I'm going to let you guys unmute yourself and ask any questions. Was it better today, like easier? You were able to decide the design pattern and you were able to draw it yourself, right?
How is this different from command pattern?
Sorry?
How is this different from command pattern? Because there also you have an execute function and there also there is a caller. So except the context where we can see that, there is a strategy of sorts here, looks like more or less same, no?
So we will do all the comparison once we are done with behavioral. But for now, can you tell me what is the crux of command design pattern? Why do we use command design pattern?
The intent says that to do undoable operations, and to keep the stack of all the executed commands so that we can undo.
Not undoable. We want to keep a record of all the actions into an object format. Now, if you want to do undo, redo, whatever it is, that's later. The part which is the main is to save it as an object. Each of every command to save it as an object.
But then arguably here also we are saving it as an object, right? Every strategy is an object, and you are.
Yes, strategy is an object. What is an object over there? The command is an object.
Correct. So that's what I'm saying, that inside the function, things could be different, as I said, the context, but essentially it looks like same, that, okay, over there you are wrapping a command, so to speak. Over here you are wrapping a strategy.
But here you also have to run the strategy. You have to run the algorithm runtime. Right? You are changing the behavior runtime. There, are you changing any behavior? Like, are you saying that I have to run the command, or something like that, like runtime? See, the point is like this. I can see a lot of people asking about factory also. Factory is what? Creation. Command, what is the main thing that we are creating? Like we are trying to encapsulate command over there, right? Here, what is the point? Here, we are trying to have different strategies.
Keerti, instead of using a set payment strategy as a method, could that be executable, like in the code, be written part of constructor of my payment processor? I could have written it.
I'm so sorry. Give me 1 sec. Hi guys, I'm so sorry. I just got my YouTube ka silver button.
Oh, congratulations.
Sorry.
Yeah, congratulations.
Sorry, that's why someone was on the door. Yeah. Okay.
Yeah, Keerti, so I was saying that instead of having a set payment strategy as a method, couldn't we create a constructor of my payment processor to execute my factory class, like factory you had a separate method, set payment strategy.
So
Can't that be done in constructor of my payment processor?
you could, but see, the why I wrote like that was that I want to take runtime. That okay, now I am getting this that this is the enum or the user selected that I want this type of processing, and now I want to set it. You can obviously do it while setting the processor also, but if you think about it, the processor will be created earlier, and then you will later decide that what is the payment processing, like how you're going to do it, right?
Okay. And here we are saying the factory for my payment processor, we are using a factory, correct? When we say that this is a combination of my factory and algo, this strategy. So the context is being done through factory class, right? I'm creating my context through factory. Is it correct to like
So my
that is what
context is the one that has the factory. Let me share my screen. Yeah. Give me 1 second. Also, I will take questions for another 5 minutes. Okay, so if anyone wants to take a break, can take a break, and then we will go ahead with the next design pattern. So here, if you can see, I am in where strategy and factory. So here you can see that in this is the context. Here is where I am calling this factory a create payment strategy. Right. So for now, for making it easy, I just made this a static so that I know I was lazy to create a, like why to create a style factory ka object when there's only one function, right? So I usually make it a static and just call it like that, right? So, so there's no hazard. I made it static.
Okay.
But this isn't simple factory, right? This is just an if else statement, which you named as factory.
Sorry. So if
this
you
isn't simple factory design,
if you move the what is in simple factory, we just take the if else and we move to a separate class.
Absolutely right.
Right. So that's what we have done over here also, no?
So in design pattern, basically you have to understand the crux, right? Writing the code can be like done in aggregation, association, like in whatever like flexibility we want, right?
The point is extensible, maintainable. If I add new algorithms, if I add new strategy, I should be able to do it as easily as possible. So basically, if I add new strategy, where the changes will happen, I will make the change in this factory, correct? Where else will I make the change? I will just add one strategy. I will not make change anywhere else. Right?
Yeah, right. So basically we are encapsulating the way you said the family of algorithms. But one doubt, like you were saying that we are having aggregation relationship, right? Can't we just pass the parameter in the function parameter, like pass it as a parameter? Then we don't need that thing, right? Also, the statement you said that the processor.
One by one. So you're saying the payment strategy, instead of having it inside the processor, can't we just pass it? So that's what I passed it only, no, inside.
Yeah. So okay. So no need to like there is not a force, right? Hard and fast rule of having the aggregation only.
So this is aggregation. There is no hard and fast rule of having composition, but usually composition makes more sense. So in most of the places you will see composition. Why? Because it does make sense, right? You think of it in a very simple way, that why will a strategy exist without a processor? Why would you want to have a strategy without a processor? If
But
there is
maybe
no
there
one
are
to process my payment, then for what have I created this strategy?
Okay, but what if we are having multiple processors? That multiple processors can have access to one single strategy as well, right?
So if you want to do like that, then it will be aggregation, not composition. But usually that will can you think of a case where that will happen? Like there are different payment processors, they are using the same strategy.
For example, let's say this is a subscription payment processor. Okay. Apart from that, we can have an order payment processor. Apart from that, we can also have some, like, let's say, yeah. But
so in that case, you can do like that, but you will have like different, say, I think factories also, correct? Like for every like you will probably have different factories or same factory. Like then you will have to decide accordingly that for different processors, like you want to add a strategy or do not want to add a strategy. You can do like that, then it will become aggregation. we could also talk about abstract factory and all that, but you get the point, right?
Yeah, so in this case, it's not necessary to have a composition or aggregation, right? We can have an association as well because let's say you said a statement that the processor has a strategy. This statement makes sense, right? But this also statement makes sense, right? That the processor can call a strategy or has access to the strategies,
See,
right?
it is not just about making sense in English, right? You have to think about the processor uses a strategy, okay? But is anyone else using the strategy? Like, doesn't the processor like this? If it is like that, so strategy is sort of a member of processor. It does make sense like that, right? That it is a behavior or a characteristic of the processor, that this is the kind of strategy that we are trying to follow. Correct? That is why has-a makes more sense over here than uses-a.
Okay, got it.
Can
It's
you
not just about following in English. You also have to think about the meaning. Like, what it has the behavior of this kind, like it has the behavior of this algorithm.
But having these relationships are
Keerti,
also flexible, right? Uh, the the end goal is to follow the crux that we have to encapsulate the family of algorithms and we have to make the code extensible. That's it, right?
yes, yes.
Exactly. Yeah.
Yeah.
Someone,
Can you please draw UML of this thing considering factory to be an abstract factory?
yes, let's make it. Okay.
Yeah.
Guys, I am muting you all one more time. Sorry about that. Okay. Let me share my screen. Okay. So, what was the UML so far? The UML was that there is one payment strategy. Then it has, say, make payment. I'm not drawing boxes, guys. Understand that much. Okay. Then from here there is, say, PayPal ka payment strategy. There was credit card payment strategy. There was crypto payment strategy. Correct? This is what we have done so far. And also there is one payment processor. So right now, let's say this is aggregation. This was the earlier one that we had drawn, right? Yes. This is the one that we had drawn. Now what is happening is that here inside this, like this is calling basically accessing the factory where we are creating. So what is the, let me see the name. What is the name of that function that I've written? So the name of the function is create payment strategy. So this is create payment strategy, right? And what is it returning? Let me write it properly. So this is a payment strategy factory. And inside this, there is, say, a method, and it's called, say, payment strategy. It is returning this, and it is called create payment strategy. Now you understand, right? That string, we are passing the method. So this is how it looks. Actually, I should be writing it outside. It should be like this. Payment strategy, like colon and then payment strategy. So this payment processor is calling the factory, and now I have composition, so it has payment strategy. So this is where we are creating. Yes. Now does it make sense? Now factory and strategy. Now factory uses or has, or what is it? Factory can use payment strategy. Let me see the chat. What are you guys seeing? Association, right? Yes. Why has a Shubhit? So factory is using the payment strategy. Can access the payment strategy. It is creating the payment strategy, but it is accessing it. So it is returning it or it is creating it, but it is accessing it. It does not have a payment strategy. Yep. Yeah. Cool. So makes sense, guys. Can we move ahead? I'll pick up more questions later, but I think more or less most of you have understood. So happier today, easier today, yes. I am trying to make it very, very easy, guys. Can I get more people like attend till the 5th week, please? Happy, yes. Confident, thank you. Earlier, easier than last class. Happy to hear. Okay. Awesome. Starting with the, a participant has said the speaking language to Hindi. Who is doing this, guys? Please don't do all of this. Yes, focus. Okay, cool. I don't know why I've given you the right though. I will check it out later. Cool. Everyone, full focus over here. Now I'm again going to give you one scenario, one use case. You have to try solving it yourself, and let's see if you can come up with a solution yourself, and let's see. Okay. So currently we are Amazon. Okay. We are all Amazon, and we have delivery system. So we have a delivery system, but right now we have only in local. Okay, so only say within a particular city or say within India, we have a local delivery system. Okay, now inside this, what are things you do inside delivery? You say you verify your order. So you do verify order. You assign a delivery partner. Assign a delivery partner. What else do? You track delivery. Right? So you do all of this. Yes, everyone does all of this. Refund, blah, blah, blah. Multiple things you do. Now, what am I saying is that Amazon has grown. We are very good business people. So now, because Amazon has grown, we decide that we are not just going to have a local delivery system. We are also going to have an international delivery system. Okay? And suppose tomorrow I decide that I just don't want one local, but maybe I want different delivery systems, say for North India, South India, because it is getting huge. I have to do too much, right? Suppose I have to do all of this now. Now, when I create another delivery system, I want, now this is different. Now, the way things happen in international might be different, but I want them to follow these things. Like I want them to verify the order, assign the delivery partner, and track delivery. Like this, though, at least they have to do. Make sense? So basically, I want the international delivery system to behave like my local delivery system. However, this guy was doing, this guy has to do. Very nice. I can see someone saying, send them a contract. Yes, we'll send contracts. That is how we are going to code. That you send contract, that this is what you should be doing. And if you think about it, we should be having code checks that whatever things were happening inside over here, we want to have the same behavior. Does this make sense? Does the logic make sense? I can see someone saying prototype. Prototype was what? Prototype was creational. This is what? This is what? This is behavior. Again, I'm giving you 1 minute to think about it. I'm going to stop talking and give you a minute to think about it and see. Okay, I'm looking at the chat and all. Not understood completely. Okay, let me say again. So there's a local delivery system. They are following some particular things that I have to do this, then I have to do this, then I have to do this. Now, whoever comes up with another delivery system or if there is a copy of that, they have to copy the behavior. So I can see some people saying prototype. In prototype, we were creating same like objects and they had to do that, right? There was a prototype and we were doing that. Right now, what am I trying to do? I'm trying to copy the behavior. Copy the behavior. Whatever behavior was there in local delivery system, verify, assign delivery partner, track, same behavior should be there in international delivery system. That is what I am trying to do. Copying the behavior, right? So if you do not know any design pattern, if you have no idea how you would do it, how would you actually make this? Someone is saying Control C, Control V. Yeah, very good. Very extensible and non-repeating code we have written, no? Not at all redundant. I can see a lot of people saying interface, generic, class inheritance. Atul is saying chain of responsibility. Why chain of responsibility? Chain of responsibility is like at runtime you want to decide that after this what is going to happen. We will compare all that. Don't worry. For now, the point is that we have to copy the behavior from one to another. Okay. Yes. Now, okay, let's see. So basically, I want this international delivery system to have the same behavior or to follow a template. To what? To follow a template. Basically, there should be, say, suppose there is one international delivery partner. So give me 1 second. So suppose there is one international delivery partner. So over here, so this should be coming from somewhere which has a template, which is saying that you have to have these functions. Like for example, so I have verify order, assign delivery partner, and track delivery, right? So I have, say, a class. I do not know what this class is. Inside this, I have one method which is saying perform delivery. Perform delivery. And inside this, I am saying that verify order or assign delivery partner and what track order, right? So these things I have to have. Now I could see that a lot of you are saying interface, right? So obviously this guy, the international delivery system has to have these three methods, correct? Now see the point over here, the different point over here to notice over here is that I should not be able to override this perform delivery, correct? I have to follow the same delivery. I have to follow the same method, but I should be able to verify the order, assign the delivery partner, and track it according to myself. You understand the tricky part over here? The tricky part is, let me say that again. So there is one base class. Okay. What have I named the base class in the code? I do not remember that. Let me see. Give me 1 second. So there is one order processing template. I have named it like this. So in this template, I have a process order method. And inside this, I am saying that what all things you have to do? You have to verify the order. You have to assign the delivery partner, the delivery agent or whatever, and you have to track the delivery. Correct? Now you have to do these things. So these three functions should actually be abstract. So if you think about it, these three functions like verify order, assign DP, and track delivery partner, these three should be abstract. And this is my class. This is my one class. These are methods. Now from here, like I am getting another class which is called local order processor or international order processor. So I have international order processor. And I have local order processor. So there is another one. There is local order processor. Right? So if you see international order processor and local order processors, they should be able to override this. This is abstract, right? Why they should be able to override this? Because they will verify the order in their own way. The local one will do it in its own way. The international one will do it in its own way. The assignment will happen in its own way. Suppose the algorithms are different. The tracking will happen in its own way. But both of them have to follow this. Is this point clear? That this is the template. But these are the methods that they have to follow. These are the abstract methods that they have to have. So there's a tricky point over here. It is not like all the functions are abstract. You understand? In fact, we should not let them have this. So for Java people, that is what final does. That I should not be able to override this particular method. Or for C++ people, you have to make sure you do not make this virtual. Don't make this virtual. For Java people, make it final. Why? This isn't just an interface, correct? This is not an interface. Why am I saying this? See, basically, I should not let my concrete or say the international order processor, local order processor to be able to override the processing order. I want them to follow these methods only. That you have to first verify the order, assign the delivery partner, and track the delivery. But how you do it, the abstract classes, that you have to override and do it in your own way. Yes, so process order will always run in its base class, right? Doesn't it make sense? Because I will not, like the international order processor or the local order processor should not be able to override this. And this is what we are calling template. This is the behavior that you have to follow. Rekha is asking, how do you enforce it? As I said, in Java, you can make it final. What does final mean? Final means that you cannot override this particular method. In C++, if you do not make it virtual, always a base class will be called. You should not be able to override it. Yes? Raj is saying like director doing for the builder. You can say it like that. So I can see a lot of you connecting multiple design patterns. Here, what is the point what is the crux? We are setting a template. This is the template, but the template is also saying that you have to have like these particular functions, these abstract methods, you have to implement them also. See, again, you are able to tell the solution yourself. What was the problem? I want international order processor and local order processor to follow these methods. I want them to follow these methods, but I want them to be able to have their own implementations. I want them to be able to have their own implementations. Verify order or assign delivery partner or track delivery partner according to yourself. But processing, you should be like you have to follow these particular methods. Make sense, guys? Vishweshwar is saying, can we use a strategy to implement the abstract methods? So if you use strategy to implement the abstract methods, you can. So you will have different strategies, but you will have to call these methods in a particular way. See, the point of having them is different. What is the point over here? There is a template. You want them to follow a template, right? What is the strategy? That the algorithms themselves is different. Here also algorithm is different, but see, verification is also different, assigning is also different, tracking is also different. There are like a lot of methods that have to be done. It's not like just one algorithm. There are multiple steps that need to be performed. Yes? Doesn't it make it redundant? How is it making it redundant? It is not making it redundant. How is it not making it redundant? Because I'm saying that this is the template. You don't have to copy paste the template. You don't have to call this again and again process order. But this though you will have your own implementation, no, of verifying, of assigning, of tracking. The way you're going to track in local and the way you're going to track in international is going to be different. Yes? Where are we forcing them to call process order? We are not forcing. Okay, let me just show you the code first. Let me show you the code first. It will be clearer. Everyone can see the code. Yes, strategy, template. So this is the one. So you can see this is the code that we are looking at. This is the template. This is the one that I was talking about. Okay. Now you see in C++, I made all of them as pure virtual. Pure virtual meaning what? That everyone that inherits from this order processing template have to implement verify order, have to implement assign delivery agent, have to implement delivery, track delivery. But the processing part, not necessary. Like you should not be able to, in fact, override this because you have to follow this function only. Like in local order processor, you will see these three functions. You will see as verify, assign, and you will see track. You will not see process because it is not virtual. Like in Java also, you see Java code here. I should actually make this final. So I can make it final so that they cannot override it only. So here there is process order and then there's these three. So these three are abstract, but this is not abstract. This process order is not abstract. So these will not be overridden. But this has to be followed. So these will be overridden. This will not be overridden. Process order is the template. You have to follow it. These are basically your own implementation. Do it separately for local order and for international order. Let's look at it again. Let's look at the main. So if you look at the main, all I'm saying is that this is the template. Now you can either do local or international and you're processing it. It is very simple. This is probably the easiest design pattern that you will see. This is the easiest design pattern of all. What are you doing is just setting a template, follow this function. These are the abstract methods. That's all you have to do. So here you can see these are the abstract methods. Here you can see these are the abstract methods. In the main, what am I doing? Local order and international order. I'm just doing local order ka process order or international order ka process order. I'm deleting it there. Simple, sweet and simple. Let us run the code also. Amazon order. Here you can see, what did I say? Local order, international order, you process it, right? So when we see actually, so you can see over here, processing a local order, verifying a local order, assigning a local order, tracking. So the same steps are being followed, but here it is for local, here it is for international, right? Same steps will be followed. Here, if I had done, say, if this would have been international process, international order processor, if I would have created 2 international orders, same simple thing. No, I'm just saying key international instead of local. So now it should be able to follow the entire thing by itself, right? So here you can see processing a local order, processing an international order, right? So it is doing the same thing, verifying, assigning, tracking. So it is following what? It is following the template. Where are we setting the template? We are setting the template over here. And what are we doing over here? We are just doing order processing template and then creating the process. Make sense? Can I get yes, no? Any part of the code that you would like to see again? I can see a lot of yeses. The template can be modified is the question. So if you have to modify the template, you can modify over here, right? Like in the process order. If you want to change the process, change it over here. Yep, but I can see what if there are different steps of processing order for local and international. In that case, we might not be able to use the template. Then it is not template design pattern. No, template is what was the problem that we were trying to solve. We want to have the same steps. That is the problem that we are trying to solve. Don't force fit a problem. The problem is that we want that, it should follow the same thing. Yep. Okay. We can do this using chain of responsibility. Okay, now let's do one thing. Let's compare all the design patterns and let's try to understand the differences, the behavioral design patterns. By the way, everyone, congratulations. We are officially done with all the behavioral design patterns that we are going to study. After this, we are going to move to structural design patterns. So you are done with 2/3 of the design patterns. You're done with creational as well as behavioral. So congratulations to all of you. Feel proud. We will be able to implement these very soon. I hope this is a satisfying class, motivating enough for you to show up the next 2 days. For simple motivation, guys, just take pictures, put it on Insta, LinkedIn, increase your following also, increase your engagement also. Do all of this. No, use this course as much as possible. Participate in the hackathon, win the prizes. There is so much for you to do. I don't know why you guys are not so active. Okay, so please be more active. Take full advantage of me. Okay, cool. Okay, what are the different design patterns that we have learned so far for behavioral? For behavioral, what are the design patterns? What are the different design patterns, guys? I can see command, observer, strategy. Okay. So I can think the first one that we learned was observer. After that, what did we learn? Command. Okay. After that, what did we learn? Observer, command, then chain of responsibility, correct? Then what did we learn after chain of responsibility? Iterator. Very good. After iterator, what did we learn? Strategy, which was today. After strategy, what did we learn? Template. We nicely filled one entire page also. Okay. Now, don't unmute yourself until I ask your name. I'm going to ask you questions now. Okay. Don't start leaving the class because I'm asking you to unmute. It is okay if you do not know. Okay. You can just ignore. Priya Jha. Priya. Can you unmute yourself? Or Sujay N. Or Vishweshwar Bandle. Okay. Shobhit Bhatnagar.
Hi.
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 Can you tell me what was observer design pattern? Like what did we do?
Yeah, in case of observer, there will be some observer. In case of some of the we observe one of the object, and whatever the changes, some changes will happen there. Then we will notify to
Right.
other like subject observer.
Correct.
Means like there is a one subject, and any change happened in the subject, we will observe send that changes to observer.
Correct. So we have loose coupling. There is one-to-many relationship, right?
Yes.
Can you tell use cases? Like we had discussed a few use cases.
Observer.
Anything.
Yeah, let me give some example. Like whenever in a hospital management system, whenever the new patient will come, there are a different department. Like one is handling all the like bed availability and all those things,
Very good.
and another one is like finance department. So whenever we create one patient in the database, then we have to send the like those are the different finance department and like bed management system. All those systems are like observing the that creation like first.
Yep. Thank you. So weather, traffic, finance, we had taken these examples as well, and you took good examples. Thank you. Okay. Coming to say Rashi or Rama, guys, don't leave. We have one more design pattern to cover. Okay. Leela Krishna or Lavesh Garg. Can one of you unmute yourself? Karan.
Yes, Keerti. What design pattern?
Command design pattern.
Command design pattern. Okay, so in command design pattern, we have one invoker, we have one receiver, and we have one abstract command, and we have concrete commands, right? So first of all, uh, client client makes the object of invoker. The flow goes to the invoker, then all the flow goes to the concrete commands, and then receiver there is a one receiver is a guy who actually do the things. So in command design pattern, what we are doing, the crux is we are encapsulating the request or the command as an object. So so command has one execute function. All the concrete command have to override this execute function. So invoker there is a create invoker which has a execute function which calls the execute function of the concrete commands, and the concrete command calls the different function which are present in the receivers.
Very good. Can you give example also?
Yeah, so basically we have to perform different commands. For example, if we have to perform copy command, save command, undo command. So copy command, save command are the concrete command, and इनके जो parent इसका जो parent है वो हो जाएगा हमारे पास I command, which is an interface, and there is one invoker and one receiver.
Very good, very impressed. Thank you. I guess no one has a confusion between observer and command, at least, right? These are very different design patterns. Correct? I hope no one has confusion between at least observer and command. Okay. For chain of responsibility, who is going to tell me? Arijit, Anubhav, or Anita, Chevanti, Mohit Rajput, Mohit Sinha. Okay, any one person.
Yes.
Tell me, chain of responsibility.
Yeah, so basically, chain of responsibility means that we are allocating which object will take up the responsibility in runtime. So basically, our client will, so we have a handle which has a function that is handle request, and each concrete class will implement that handle request. And it also has a function that is like set next handler, which will basically decide what is the next handler after the work is done. So, I mean, that is the crux of the pattern.
Dynamically run at runtime.
Yeah, at runtime, that is the crux of the pattern. So basically, examples for this would be, let's say we have a bug, right? And we have several teams. So that is like which team allocates the bug to the next team. That is first example. The second example would be a hospital design system wherein a patient could be, I mean, so the first he's looked into the reception, then he's transferred to Dr. 1, Dr. 2, Dr. 3. So yeah, these four examples, yeah, that are on top of my mind.
Right. Another example we had taken was ki we want leave, like who is going to do it, like manager or CTO or whoever, right? That was one more example that we looked. Thank you. This was is there any confusion between chain of responsibility, command, observer? Any confusion between these three? Anyone? No? Cool. Okay. Iterator. Who is going to tell me iterator? When you have to ask doubts, no, 10 people will say together. But when I will ask you to answer, no one is going to answer. One person, just unmute yourself and tell what is iterator.
Yes, so basically this pattern allows you to basically encapsulate the basically traversal of a data section. For example, if you have a tree, binary tree, and you want to do a certain level of traversal, so basically you can create an iterator, which basically finds the successor, and then basically when you call next on this iterator, it will basically directly point you to the next element. So it's a basically an way to encapsulate the traversal of a data structure. So it has a ref which gives track of a current element, and you can move to the next element and the previous element optionally.
Correct. Very good. Basically, there's an aggregate object, and we have to access elements of the aggregate object. Aggregate is probably the list or the collection or whatever, right? So aggregate is an important term. Just remember that as well. Can you tell me a few examples?
So first is the tree traversal example.
Okay.
Second thing is basically linked list is also an example. Basically, when you want to traverse a linked list.
Give some examples other than the normal DSA, like so that it is clearer.
If we want to filter based on any rating or like a product based on alphabetical order or any
basically you have song, the example that I guess you are talking about. We had talked about this. So songs basically media player. We had said that we want the list according to say rating and say any genre or something like that. Correct?
Yeah.
Thank you.
So can Instagram pictures on feed be an example of iterator design pattern?
If you want in particular, like if you have an aggregate and you are doing like that, you can, but usually that would not be the case because it is ever growing. It is not an aggregate and all of that, right? It is not like a very good example of it.
So for example, my .next will give me next 10 profile pictures with ads that I want to save.
Can do. Okay. Any confusion in these four design patterns? Any confusion in these four design patterns?
Hello, Keerti ma'am.
Yeah.
Ma'am, I want to ask about this command pattern. Here we are having invoker and receiver two classes, right? Where invoker is we are using invoker for encapsulating the commands. And in receiver, we are having all the business logic.
This is actually running the command.
Okay, but why we need two classes? Like what for encapsulating there is a separate invoker. Why we are having separate?
I had talked about this, that invoker, you can call your main or your client itself as the invoker. It is not like it will become invoker. Basically, wherever you are calling the command. who is invoking the command is your invoker. It could be your client, it could be your main, wherever you are invoking it. That is your invoker. Somewhere you will actually call the command, no?
Okay, so invoker is something which is optional, right? We don't need invoker as a mandatory that we have to implement it to encapsulate.
Just like in builder design pattern, your director was not mandatory, right? It was optional. Like you can have director or you can have it in like client or main, just like that. In command also, invoker is not necessary. Like wherever you are calling the commands, you can call that itself as invoker.
Okay, got it. Thank you so much, ma'am.
Any other questions anyone has in these four? Okay. Who is going to tell me strategy? Strategy? We did this today. One person, come on, unmute.
Hello.
Yeah. Right.
Yeah. So in strategy, what we're doing is we have multiple different options to choose from. It can be different strategy, it can be different patterns or algorithms that we have decided. So we will have different options to choose from, and we want to choose the optimal one based on certain criteria on the fly. Like it has to be on the runtime and based on different criteria. For example, we took the example of Uber or Ola, that it can be based on location or environmental conditions and everything. We will choose the algorithm during runtime. So in that case, when we have multiple options and we want to choose something during runtime, we can follow the strategy design pattern.
Yes. Thank you. Driver matching, payment processing, delivery partner matching. One of the most sincere students. Thank you. Okay. Template, who is going to tell me?
Yes.
Yes, tell me.
We will have a set of steps to be followed, and this needs to be same across different child classes. Example that we took is we have a local delivery and international delivery. We want to follow the same steps, same sequence of steps, but how the steps are implemented are different.
Rest. Yes, very good. So you can say that you have basically a skeleton of algorithms or a template of algorithms. Okay, so a template of algorithms or steps that you need to follow. Yes. Yep. Thank you. Everyone has understood this much, like behavioral clear. Can we move? Like today, I will not cover the next design pattern entirely, but I will give you. Okay, suddenly everyone started talking about I can see skeletons, and I was like, what? Now it makes sense. Okay, cool. Anyway.
Sorry,
Yeah.
one question regarding template. Why template is called behavior here? Why it is a type of behavior pattern?
Because we are copying the behavior, that the behavior has to be same. Now, when we do structure, no, we will understand how structure is different. Like between behavioral and creational, I guess you are able to understand properly, right? That you are copying the behavior. Now, when we look at all the structural, we will understand why this is structural, why not behavioral, and then we will at the end compare also behavioral versus structural.
Okay, thank you.
Yeah. Okay. Everyone, full attention for next 10 minutes. I will just introduce you to a...
I have one question regarding strategy pattern.
Yeah.
You said that we can think of it as a composition relation between the example that you showed, the processor class. So in that code, I couldn't see that how the strategy is tightly binded to the processor. Like I couldn't see any nested strategy that you implemented inside processor, so that strategy is the part of the processor. It cannot exist without it. The code was totally, at least for me, it was like looking just for aggregation. So I was not able to get that feeling. It's kind of composition.
So we had discussed this, right? So in the simple strategy, the code that you saw was aggregation. But when I combined strategy and factory, the code that you saw was composition. In the strategy in factory 1, if you open the code, you will be able to see that I'm creating the strategy inside the processor and I'm also deleting it in the destructor. At least in the C++, you'll be able to see the delete also, right? So just open the strategy and the factory 1. I had discussed this, that in the normal strategy 1, it is normal aggregation, the code that I've written, but it should not be like that. It makes more sense that you create the strategy only after creating the processor, right? Only inside it. Doesn't make sense to have a strategy outside without a processor.
Keerti, in strategy, the payment processor, how many payment processors should we be able to generate? Well, will one system like Swiggy would have only one payment processor, or there could be multiple instance of payment processor?
Are you saying that we should combine singleton and this?
No. I am trying to understand that will it be one, or like will it? How will it be? Like right now, you're saying it is abstract factory, right? That we are combining that to in strategy what we did.
Not abstract factory, but yeah, you can combine the both. You can have single instance of the processor, and then
No,
that.
but how is it in actual system? I am trying to understand that. Will it be one or many processors?
Usually there is like a pool of processors. So
Okay.
we will talk about this more in detail. So usually, okay, guys, don't leave. The class is not over. Give me 10 more minutes. I want to just set one context for the next design pattern. Then you can go. Okay. For this, just quickly covering it. See, usually there's a pool of processors or DB connectors. We will discuss this in detail. You can have one also, but one is usually not enough. So like you do not want the entire load to come on one like that. You can think. Don't think about this so much right now. We'll cover this.
Okay.
Okay. Guys, everyone full attention for just 10 minutes more. I'll set context for the next design pattern because we have to cover 8 design patterns this week. Okay. So just let me set the context and then we can discuss the rest tomorrow. Okay. Very, very simple use case I am telling you. I'll tell you 2-3 use cases and you have to start thinking about it. Currently, you have some data. Okay. Everyone full attention over here. Okay. Currently, you have some data. The data is in XML. So you have XML data and you have a tool. You have an analytics tool. Okay. So you had the XML data and you bought this tool now only. Okay. Now this tool is like very good in the market. So company said that use this tool and all, but the tool takes data only in JSON, not in XML. What are you going to do? You do not know any design pattern. You know that your code should follow solid principles. You cannot start crying that, oh, I should have written my code better. Now I have code in XML data. Not possible. Cannot give that answers to manager, right? What answer are you going to give? Let me give you another example. Like for example, there are different modules that are giving you some location. Someone is giving you location, say in longitude, latitude. Someone is giving it to you in latitude, longitude. The ones who are giving it to you in longitude, latitude, say are giving in strings. And these guys are giving it to you in decimals. You're getting basically the data in different formats. Now what you need to do is that someone is calling some APIs. Now for that API, you need to call in say latitude, longitude only, but say in string, not in decimals. How are you going to do it? Yes. Do you understand the problem? That we have the data in some other form. It can happen, right? Suppose we are working with some 3 parties or some third parties or with some modules. So they are giving us data in some API form, but the one who needs it, suppose this guy needs it in another form. So we need to convert the data somehow over here. Make sense? The problem that I'm talking about? Yes? Everyone, the problem is clear that we are getting the data in one form, we need to convert it into another form. As simple as that. Now, this, as I can see a lot of you are already saying, this is called adapter design pattern. But adapter also has 2 types. One is class adapter and one is object adapter. And I don't know how many of you know this. We will look at the detailed code tomorrow for both class and object. But for now, try to solve this yourself. That how would you solve this? That if you have data in one form and you have to convert it into another form. Let's try to, like I will set some context for you that, okay, what is happening, what is expected and all of that. Like suppose this is your main. Inside your main, you have your XML data. Okay. And you have another class called tool. Okay. Now this is, okay, sorry. So there is another class tool. It has, there's a class tool, it has another method, say analyze data. And what it takes is JSON. Okay, it has this method. You want to use this. So you want to use this like this, and you want to be able to pass JSON over here. But you cannot pass JSON. What do you have? You have XML. You have to pass JSON. How would you do it? This is where I end the class. I want you all to try solving this yourself. And I am keeping this class very chill. But again, the next two classes are going to be, we are going to cover more design patterns. I've kept it very, very simple today, guys. I want more people, more attention and more people participating. Quiz tomorrow, everyone should have been able to do. Piyush is saying to repeat the problem, so I'm quickly repeating it. See, Piyush, right now in my main, you look at my main, I have some XML data that I've gotten from somewhere, right? So I have XML data. What I am doing is that I have another class tool, and inside tool, I have to I have a method analyze data, but this method, so this is some third party module or some other team is working on it. Okay. Now this needs JSON. This needs JSON. We do not have JSON, right? We do not have JSON. We have XML data. So we have XML data, but this guy is expecting JSON. How do I send JSON when I have XML data? I want to analyze this data only. This is the problem. Or you can say the problem is that you have your location in longitude, latitude, or some in string in decimal. You want to use the location in latitude, longitude, and string. I can see so many people are leaving. So it's okay, but at least next two classes be on time. Understood the problem? Okay. I am letting you guys go early today, but okay, let me give you the permission to unmute yourself. Any questions anyone has, feel free to ask on Discord. You can ask me now also. Like, I will not be answering questions because people are leaving. But if there's anything else, today's class was...
I have a very different question. Like, when we are coding, so do we need to define the classes as well with the names, like this is the strategy class or like that, adding that strategy keyword? Was this the convention, or we could name it any way we want?
See, strategy, usually no, you don't need to add it. No. But usually what happens in a comment, like factory, you will see people mention factory, like, okay, this factory, pickle factory, so that when someone else comes and reads it, it is obvious. Similarly, for strategy, it does make sense to just add one strategy or this algorithm. If you just write some algo or strategy, basically some way so that another person comes, can able to understand very clearly, okay, this is what is happening over here.
Okay.
Keerti, I had one doubt. So template design pattern and builder design pattern looks exactly similar.
But the intent is completely different. What is the intent of builder?
We have steps to be followed in the process.
What is the intent? What are we doing? Steps to be followed.
Create subjects.
Create objects, yeah.
Here we are not creating objects. Here what are we doing? We are following the behavior. Same behavior has to be followed. Similar thing only, I agree.
The same question. Can we use chain of responsibility for this?
I could see you asking this earlier also. Why chain of responsibility? Say, okay, how would you do using chain of responsibility? Tell me.
Basically, what I understood is template is kind of process, right? Like we are following the every class should follow that process. Let's say verify, then whatever the process. So chain of responsibility is some similar, right? I mean, there also we are following some.
What we do, every handler chooses that this is where I want to stop, or who is going to be my next handler. Do I need it? And who is going to be my next handler? Remember in the bug example that we saw, the code bug, we saw that, okay, this test is running. Now I have to pass it to say team 1 or team 2, or maybe who is going to approve my leave? Is it my manager? Then my manager will decide that will it be my skip level manager or will it be my CTO for who needs to approve this, right? So at every handler, we decide who is the next handler. Versus here, what we are doing, these are the steps that you have to follow. At the runtime, we are not deciding that who is the next, like what is the next step or where are we stopping? Nothing like that. Here we have a template. that this is the step you have to follow.
So
okay.
basically, I think why he is getting confused is in chain of responsibility also you can have a standard template, right? The dot convention that we followed. But the difference is that I also got confused. The difference is that in chain of responsibility, there are two different classes or objects in that case, or handlers that have different work altogether. Here in a single object is having 10 different things, is doing 10 different things. So that is the difference. If you can basically what do we call that, separate, decouple, verify, and track payment into different classes, then you'll be able to use chain of responsibility here as well, right?
Yes. So see, there are two things when you are understanding differences between two design patterns. One is to understand the intent, the difference of the intent. One is understanding how it is implemented, like how is the UML different. So what you said, UML is different in that sense, correct? But what is the intent is also different for both.
Okay.
Yes. So see, again, I am repeating this, like in builder design pattern, not necessary you add a director, like in command, not necessary you add an invoker, but the crux will remain same. Understanding the difference that there we are creating objects, here the behavior is different and how it is different. What is the problem that you're trying to solve? That is important.
Got it. One more question I had, right? When we were doing factory with strategy. So, I mean, if I go to the previous classes of creational design patterns, we use factory when creation of objects is completely different. But in this case scenario, the creation of objects is exactly same, right? There's no different way to create an payment strategy. Like all you have to do is init the class, or there might be so you can have some conditions, but that is something that in builder design pattern my director could have, right? So why didn't we go with builder design pattern here?
No, in factory though we encapsulate where objects are of similar objects.
Similar objects which have different which have different creational methods. In builder the creation might be complex, but the steps followed are the same.
But in
The
creating
strategy
the
is not complex.
strategy is not complex. You don't have to follow any steps. No, why use like builder? It will be an overkill to use builder over here. Like you are only saying that creating a strategy is very simple. Just do a new strategy. But builder is, when do we use builder? When it is very, very complex. And there are steps to be followed. Are we following any steps while creating the strategy?
Depends, right? If there are two
Yeah,
or three different, like it will
yes.
depend on the use case.
Yeah, it's like different strategies for like encapsulating algorithm. But when we are creating, we can choose, like we can use builder or we can use factory. So the example which you gave was simple. We just directly used a simple factory. But yeah, what he's saying, if it is a complex object to create, we can go for builder plus strategy also.
Because earlier he said it is very simple. So I thought that he's meaning simple object. But if you are meaning that it is a complex object, then yeah, you can use builder plus strategy. Like the point is that you can combine creational and behavioral. Strategy, we have to create strategy, so you can use creational design pattern.
Okay.
Keerti, one more thing. See, anyhow, when we're saying that these are behavioral, like in strategy, anyhow, we have to invoke an object of an algorithm, right? Whichever algorithm we are writing. So that is itself also, first we are doing creational, and then we are looking at its behavior.
We are creating the strategy and then we are looking at the behavior. That is why for creating, we use the creational design pattern, which is either, as he said, either it can be builder or it can be, say, factory, how I showed you.
So that means in any, like in overall picture, when we are designing overall business problem, we always, like I had asked this earlier also, we will always look at first creational and then look into behavioral, right? Like as a business problem.
I did answer this, right? So it depends on the use case. I'll give a simple use case. Now, this is for a company I worked with. Example being, you have adapters which are linked to your third-party systems that are ATSs, and at the end of the day, after doing processing on the profile, you're creating a profile, user profile. What do you do then? So here in
it's structural, you're not using creational, like
Yeah, I mean, first you're using structural, then you're using behavioral, depending upon the algorithm in the adapters. And after you have done all the processing, then you're finally creating an object. Right.
I couldn't get it though, but as we go forward, then maybe it is more clear. How do we like juggle between creational and see now, right now we are between creational and behavioral, and tomorrow we'll add or day after we'll be adding structural also. Then how we combine all three, that maybe we will
We have 2 more weeks to go, don't we?
okay,
Yeah,
okay.
it's like identify requirements, and depending on the logic, you identify whether you want structural or behavioral, like depending on what problem you are solving.
Yes.
Okay, fine. No, I'm just getting little confused because although I have understood the patterns, but when I say I'm looking at behavior, but to have behavior, I need to have an object for it first, right? So that is why I'm getting bit confused. So I understand what we did in creational, what we did in structure, behavioral, right? But how they are getting interlinked, that we'll see later when we go forward in the class, right?
Yep.
Okay.
So, Keerti, any books that we can read along?
There are so many. There's Head First, which is very common. There are more. Probably remind me on Discord. I can probably share a link.
Sure. Okay.
If you want to really go for core, Gangs of Four you can read, like
Yes.
from where it all started.
I actually opened Gangs of Four, and so Gangs of Four are the people who actually created the design patterns. That's from where
So
design
Gangs of Four book you can download and check. That is available free only if you want to check.
And Kirti, one more question. This word encapsulation, okay, it has itself lot of meaning. So when you are using encapsulation, it means, am I hiding? Basically, it is data hiding, is it? Well, hiding the implementation, hiding the data, hiding. Well, like, what exactly?
That is
Because
abstraction.
Basically, you whatever the client was directly using it, you take that thing out and put it into the other class. So now those things.
invariant, creating invariance, like you are creating one indirection or invariance, you call it. I don't know. Well, exactly what is the meaning of encapsulation? Because I've been asked this once by someone, but I couldn't answer it properly. What is encapsulation? Because normally you say data hiding, right? Or hiding the member entity, hiding like interface is also encapsulation,
So
right?
there's a very good example for this. Let's say, I mean, this is what my teacher gave me. Let's say you have your parents' anniversary. So you need to buy 2 gifts. One is for your dad, one is for your mother.
Yeah.
And I mean, since they are a unit, you need to give them both the things together, right? So your gift trap here is what encapsulation is. Basically, your mother's gift and your father's gift, you're keeping them inside a single gift trap and making it as a single gift. That is encapsulating both the things.
See, yes, very good example, by the way, very good example. But the main thing is that we are restricting the access also. So the access modifiers also come into picture. So basically, when not everyone can access it, but you are basically hiding and you're deciding at who can access what. You're encapsulating it together. Yes.
Yeah, whether it is inheritance or it is one class to another class, the way you are going to hide your information either within the object or it is across the objects or through inheritance. The way you are going to hide it, whether by making private or final, whatever the way, that is the encapsulation. You are hiding the data, making it restricted to the base class or one class only, or yeah.
Go on. Sorry, I was saying the term encapsulation actually comes from you can actually visualize a capsule that, okay, there's a capsule, there are data members, there is class, there is variables, class, methods, all of that into one capsule, right? So that is encapsulation. Now you're hiding that. Now outside world cannot see the entire thing. They can just see the capsule or whatever you want to show it, right? So that,
Basically, making the member data or data attributes private, you're encapsulating and making your functions
would be
public.
data abstraction,
The abstraction.
Yeah, one better example of encapsulation is like we are putting all those methods like how, and implementation somewhere else, and providing only the interface to them. So how to they can
That is
use our
also
method
data
implementation.
abstraction, right?
Abstraction is hiding the implementation details, how
Yeah.
it is happening. Encapsulation is just wrapping it together.
Encapsulation would
Yes.
mean adding attributes and methods in a class together, and abstraction would mean adding access specifiers to methods to prevent them from being used by the outside world, correct?
Right. But it is not like if you're talking about encapsulation, you're not going to talk about access modifiers or all of that. See, usually like both things are very tight, like they mean sort of the same thing, because encapsulation, when you put everything together, you also decide that what is going to be visible, right? Like, but like if you read about it, encapsulation, how the word comes. So I don't know if you've seen those capsules that, that are transparent halfly and opaque half. So transparent means you decide that what you're going to show, but you encapsulate it together, but you also abstract out that I'm going to show this information, not going to show this information, going to hide it. So I like the discussion though, the first class discussion happening now.
Keerti, I had a question about strategy design pattern.
Mhm.
So I think the ride sharing example that we discussed.
Mhm.
So we had a like separate list of strategies. For example, like strategy one, like it filters on basis of location and gives me a heap-like structure, or just a sorted list using which I can pick like what are the nearest cars. Similarly, we will have this filter for distance or the rating or like a type of car, like a luxury of car. So we have different concrete strategies for this. So like A, B, C, D, E, we can have henceforth strategies. So what if I want to combine two strategies? Like the requirement comes that, give me A and B. Then the requirement comes that give me A and B and C. Then the requirement is that A and B and C and henceforth, or A or B. So
What is the
combination
output of
of
the strategy? So here the output of the strategy was list of delivery partners. How you actually run the strategy was different, but is the combination, like the output of combination of strategies, also the same thing? Firstly,
yes, cars, but instead of running them one after the other, like the logic is to basically combining their logic. Like for example, in all these strategies, the thing which is changing is that we are filtering maybe or filtering on the basis of certain parameter. So what if I want to instead of filtering on a single parameter, I want to say this and this, or this or this.
see one very easy solution that I can give you. So they have some common methods to follow, right? So in that sense, so you have one strategy interface anyway, and then there are concrete strategies. So if there are some common things that need to be followed in multiple strategies, you can just define it in the abstract class. You remember where we are saying that make process, so or make payment. The make payment one is abstract, and they have to implement those. But if there are any common methods, you can just put it in your strategy abstract class, correct?
Yes.
So that is one way to go about it.
Yeah, Keerti, the last question, like it will be like entirely different of class. So we have to create a different strategy, right?
Yeah, but that would violate the open close principle because you already have like concrete logic for A and B. So if you like put this concrete logic for A and B, A or B, this will basically lead to exponential number of classes.
I think the simple thing would be so I will think of it like this. So any client who is using my strategy pattern or something, so first he will use one algorithm to get some data and use second algorithm to get some data as a client, and then he can just do a union the way you want, like intersection or union of all those results you are getting. I think that would be a simpler way to just do that.
Yeah, but then again, it's like you call 5 different strategies to basically form a single strategy. Like I understand what you're saying. That
I'm just
we
combining the results of
yeah, correct. I understood you. Yeah.
Keerti, when we will cover the deep, shallow copy, shared state. There was one topic.
So
Did we cover? Cloning. You deep cloning and shallow cloning and shared state in prototype.
Okay.
There was something which we missed. Like there was a quiz. I answered it wrongly. That's why I remember it. I answered it wrongly. So I.
Okay. There's not a big thing to cover. I'll cover it in the next class.
Okay. Okay.
Hello,
Fine.
Keerti. I have one question with respect to template actually. How for template pattern this solid principle is applied?
Okay. Okay, let's talk about them one by one. So if we say template, so what was the UML? Can you open the UML quickly in template? So there is one template class, and then you remember there was one order processing template, and there was local processor, and there was international processor, right? So if you think about SRP, they are following. So SRP, right? That is being followed. OCP, how that you can add another processor without making any change, who has to follow the same template?
This is not following right OCP here,
Right.
because suppose this process is a part of local a local delivery partner, then
Process is not part of local delivery partner. Process is part of template, right?
okay.
It is part of template. The three functions, remember, verify, assign delivery partner, and track delivery. Those three can be extended in any other process. Suppose North India processor, North India order processor, or South India order processor, something like that comes, right? So in that, all you have to do is those three functions have to be implemented. So you can add it and we won't have to change anywhere, because everywhere you're just using the template.
Yes. Okay.
Yes, so you're following OCP. How are you following LSP? Because everywhere where you use the template, you can use any of these local one or international one. So you're following LSP. ISP you're following because you've created the interface. We have made it small. PIP you're following because you are not dependent on the low-level modules. There is an interface involved. So yes, you're following solid principles.
Yeah. So here for OCP only, so changes in template are required.
No, changes in template are not required. Let me share the code. Give me 1 second.
If new method has to be added, new step has to be added.
If new step has to be added, then the obviously template has to be changed. No, then you're changing the template itself. Then you're changing the processes that need to be involved. What is OCP saying is that you're adding a new type of
implementation.
Yes, new type of implementation. Here you are say there is local international. Now you're adding one more. Say you're adding North Indian or South Indian.